Section 16.5, Strong Acids and Bases. Strong acids are the ones that completely dissociate. If you put them in water, they completely break apart into ions. Dissociate means to go into ions. So they break apart into whatever the proton is plus whatever the conjugate base will be. A monoprotic has one proton that it donates. And you're going to see that you're going to have 6 monoprotic acids that are strong. This is a list that you actually need to kind of memorize. As you use them, you'll remember them, but you kind of need to look at this. So mono, 1 proton, so hydrochloric acid, and you've got 3 in that group 7, so hydrobromic acid, hydroiodic acid. Okay, so there's no hydrofluoric acid is weak, but the chlorine, bromine, iodine are strong. Then you have a couple polyatomic ions. Nitrate gives you nitric acid. Chlorate gives you chloric acid. And perchlorate gives you perchloric acid. All of those are monoprotic. Okay, so 1 proton. If you have a monoprotic strong acid, the concentration of the hydronium is going to equal the concentration of the whole molecule because there's 1 proton per molecule. So whatever the concentration of the, say, perchlorate is, then the concentration of the molecule, the hydronium will be equal to that because there's 1 hydrogen. It completely breaks apart. Nothing of it is left. There's no perchlorate left. All of it's gone to making hydronium, so it's going to be equal to each other. Okay. There is 1 diprotic acid, sulfuric acid, sulfate, is -2. That means there's 2 hydrogens that need to bond with -2 to make it balance. So you're going to end up with 2 protons. So in that case, you're actually going to have to double the hydronium because let's say I have a certain concentration of this. Well, I have a certain concentration of this, but I'm going to give it twice. So it has to double the concentration of the hydronium because it can happen in 2 different stages. Strong bases. Strong bases are mostly hydroxides. You're going to see that they're the soluble hydroxides, which are the heavier alkaline earth metal hydroxides, along with the group 1 hydroxides. You can memorize essentially the group 1 hydroxide. So lithium is very rare. You are not going to see it, but lots like sodium hydroxide, you see it a lot. Potassium hydroxide. The higher ones, rubidium and cesium, those are very, very rare elements. You're just never going to find them. I've never seen them. Group 2, not the top ones, more of the heavier ones. So the calcium hydroxide, barium hydroxide. These are the strong bases. So when you put these in water, they completely dissociate. They will all basically grab hydrogens from the water itself and break apart into hydroxides plus whatever the conjugate acid is.